Okay, so I'm just going to just check on something. Yeah, okay, right. Okay, so I'm just going to screen share again. Fantastic. Okay, then, Janberg. Now, let's go back to the question. Work out the fraction that is halfway between half and 1 1/4. Okay?
Yes.
And then you've got a scale. So can you explain to me now what you've written and how is it relevant to the question?
Okay. So first, what I did was the proper fraction, so the one whole with the one quarter, I made that into improper fraction.
Mm-hmm.
So what I had done was I had done 4 times 1, which gave me 4. So then I had done 4 plus 1, which gave me 5. So here I had done 5/4. So here I explained you times a whole number. So in this case, 1 by itself times that by the bottom number, which is the 4, and then add the top number, which is 1. So then that gave me 5/4.
Yeah.
And then here I had put the 2 fractions, a half and 5/4 here. And then what did I do here? I did, sorry.
Will it be helpful to sequence this information?
Yeah.
For example,
I should
shall we do it like this? Should we put this one first?
Yeah.
This one
That one,
second, do you think? Or
oh, sorry. Yeah, that one second.
yeah.
That one third. Yeah.
And which one third? Which one?
This one.
This one here.
Yeah.
Yeah.
And then we do, what was it? Oh yeah. Now we do. Sorry. Now we do. Now you do the same thing to the half, where you times the same the denominator by the top number. So you do 1 times 2 equals 2, and then you do something to the bottom, which gives you 2/4.
Yeah.
And then what I and then here we do 5/4 and 2. Okay, so I forgot to say that we add the 1 to the top, so that'll be 2/5.
So where does the 1 go? Where does the 1 go?
Just underneath my explanation.
Yeah.
Yeah.
Okay.
And then we put 2/5 next to that.
Yeah.
Yeah. So then we do 5/4 minus 2/4. So 5 minus 2 equals 3/4.
Mm-hmm.
So we'll put that next. So then we do here. I forgot what it's called, but to find the real answer, we do 3 plus 4, which gives us 7, and then 3 times 4, which gives us 12. Then we end up with 7/8. Oh, sorry, no. Then we do 12 minus 4, which gives us 8.
Yeah.
And then we do 3 plus 4, which gives us 7. Then that gives us 7/8.
Okay, right. Now, from what you've just said there with the explanations, there are some elements of what you said actually is relevant to the solution, but there are some other aspects which are not quite 100% clear. So what I'm going to do, because I know last week we extensively looked at this, didn't we? We looked at it a lot, and I gave you, and I found a video which I think you'll find very helpful. And there's another teacher who explains a non-number line method of doing this, and also a number line method, okay? And I want you to listen carefully to what he's saying. And then I want you to then, listen carefully, make notes, okay? And then I'm going to ask you to then to revisit what you put on the post-it notes and whether you'd make any changes, okay?
Sure.
So can I just mention, there are quite a lot of YouTube channels with worked examples for GCSE Maths Foundation. I quite like Mr. Bailey's videos. He explains it very simply, He uses an electronic whiteboard like I use, and he goes through it step by step by step. Okay, and I'm just going to go through question 9, which is the AQA paper foundation, November 2019. Okay, now he's going to go through first of all using without using the number line. Okay. So he's not using the number line. Then the second one, he is using the number line. Okay. So now listen carefully. I'm going to put the volume up. Make notes. Okay.
Okay.
Away 3 we can't do, so we need to borrow one from this 6. Question 9 is one where we need to work out the fraction which is halfway between a half, 1 and a quarter. I'm going to show you how to do this, first of all, by not using the number line. Secondly, we're going to use the number line. First of all, I'm just going to say half is in yellow. So I'm going to color code each fraction. And 1 and a quarter, what I'm going to do with 1 and a quarter is change it into a top-heavy fraction. Now, the way we do that is multiply the whole number by the bottom part of the fraction. So we're going to do 1 multiplied by 4, and then add on the 1 at the top. 1 times 4 is 4, plus 1 gives us 5. The bottom number stays the same. So it was a 4, it still stays as a 4. And so in a top-heavy form, 1 and a quarter becomes 5 quarters. So why does it do that? It's because fractions are easier to compare and easier to work with when they're in top-heavy form. So as a general rule, if you've got a fraction calculation or a fraction comparison question, and you start off with mixed numbers, change them first off into top-heavy fractions. I've got 1/2 and 5 quarters, which are easier to compare. But the easiest way to compare two fractions is when the bottom numbers of each fraction is the same. And so what we're going to do here is change the half into a fraction with the same denominator, the same bottom number as this green one. So what can I do to 2 to make it into 4? What I can do is double it. But if I double the bottom number to keep it as an equivalent fraction, I need to double the top number as well. So I need 1 times 2, which is 2, and then 2 times 2, which is 4. So I'm just rewriting a half as 2 quarters. 5 quarters can stay as it is. Now, the fraction which is going to be halfway between these two will be the fraction which has a top number which is halfway in between 2 and 5. And so to work out what's halfway in between 2 and 5, we can add together 2 and 5, which is 7, and then do 7 divided by 2. So halfway in between 2 quarters and 5 quarters is actually 3.5 quarters. And so we're nearly there now. That's the fraction which is halfway between these two. It's 3.5 quarters. The only thing is, fractions should be written with the top and bottom number as whole numbers. And so what can I do to 3.5 to make it into a whole number? Well, the easiest thing to do would be probably to just double it, to multiply it by 2. But if you multiply the top number by 2, you'll need to do the same to the bottom number as well. So 3.5 becomes 7, and 4 becomes 8. And so 7/8.
Okay, right then. Jambo, can you hear me?
Yes, I can.
Excellent. Okay, right. So can you see then, in this method, by not using the number line, to find the fraction in between half and 1 1/4, you have to change the 1 1/4, which is a mixed number, into an improper or a top-heavy fraction. So you have to multiply the denominator by the whole number. 1 times 4 is 4, and then add the numerator. It becomes 5/4. Then you space the half and the 5/4 together. You have to balance it up. So basically, 4 is the greater number. So you have to then make the half into 2/4. Now you're on basically like with like. Now you can work out what is the halfway point between 2 over 4 and 5 over 4. Remember, 2 over 4 is a half, 5 over 4 is 1 1/4. Okay? And when you go in between a 2 and a 5, it's a 3 1/2, but you can't have 3 1/2 over 4. You have to double it, and then double the numerator, double the denominator, you get 7 over 8. Okay? Now, listen carefully to the number line method, okay?
Is the fully simplified fraction, which is halfway between these two, which has both the top and bottom number as whole numbers. Now we're going to have a look at using this number line to help us. So using this number line, what we could do is just plot on where half is. Half is going to be halfway between 0 and 1, which is here. And for 1 1/4, if you notice, this number line has actually been divided into quarters for us. So that's 1, 1 1/4, 1 2/4, 1 3/4, 2. So 1 1/4 is here. So now what we need to do is think, where's halfway in between a half and 1 1/4? To be honest, if you're not sure, you could even measure it because it's a nicely drawn scale. So if you were to get a ruler and actually measure halfway between them, now your ruler might be different to mine, okay? So I'm holding my hand up and saying that your measurements may well be different to mine. But mine here, between this yellow one and this green one, which is 1 1/4, I've got a measurement of about 3. So halfway between 0 and 3 on this would be 1 1/2. So you should find that the halfway point between these two fractions is about here. So I'm going to get rid of my ruler now. Just drop it down slightly. There we go. So if we look here, again, you need to notice that the fraction line has been divided into quarters. 1/4, 2/4, which is a half, 3/4, and 1. Now 1 is the same as saying it's 4/4. So what's halfway in between 3/4 and 4/4? Well, that would be 3 1/2/4. Then, as I said previously, to get rid of the 3 1/2 and make it into a whole number, I could simply multiply it by 2. And so if we multiply the top and bottom number of 3 1/2 over 4 by 2, we'll find the midpoint, the halfway point, without having to use decimal numbers. So 3.5 times 2, the top number would become 7. And 4 times 2, the bottom number would become an 8.
So, Jamberg, can you hear me?
Yes, I can.
Okay, right. Now, with the number line method, you're using the information presented to you on the line. So here, if you're using the line, in this case, you do not need to change the mixed number into an improper or a top-heavy fraction. It's not necessary. So you just work with that. And as you can see, what the gentleman did, he marked off in yellow where the half point is, where the half is on the number line, between 0 and 1, and where 1 1/4 is, okay? And then he used a ruler, but you don't have to use a ruler. You just need to make a judgment. Where is the halfway point between a half and 1 1/4? And that's exactly what the question's asking you to do. Now, again, what was very interesting was when he drew the line, okay, it then fell between 3/4 and 1, okay? And what he did very cleverly, he changed the 1 to 4 over 4.
Yeah.
Because 1 is 4 over 4, isn't it?
Because that's a whole, it becomes a whole number. Yeah.
That's right, becomes a whole number. That's it. Because the reason why it becomes a whole number, because 4 goes into 4, how many times, Camberg?
4 times.
4 times or 1 time?
Could you repeat that again? How many times?
How many times does 4 go into 4? How many times?
Yeah. Yeah, 1. 4 times 4, yes.
1. It just goes
Yes.
1 time. Therefore, it's a 1. Okay? So you then have to then find what is the halfway point between 3/4 and 4/4. And then the same thing again, you get 3.5/4. But this is exactly the end stage with the other method, the non-number line method. Okay?
I see. I see.
Now, what I want you to do now is I want you to, right, so sorry, let me just finish my explanation. Then you have to now, you can't do 3.5/4. You have to multiply 3.5 by 2, and then the top and the bottom to get 7/8.
Yes.
What I'm going to do now is let's go back to your Jamboard. Can you see the Jamboard?
Yes, I can.
Right, okay. Now, can you tell me then so when you look through the information, which information do you think we need to include now when you are now trying to get the answer 7/8?
Okay, let's go through this.
Yeah, so you want to end up with 7/8, okay?
Yeah.
So how are we gonna get? So I'll tell you what we'll do is let's just put all your information to one. Let's just reduce it and just put it to one side. Yeah.
Yes.
Let's just put it to one side so we don't have to be disturbed by it. Okay. I mean, in a nice possible way, not like disturb, but you know, like so it doesn't interrupt our study. Right. Okay.
Yeah.
That's what I meant, for want of a better expression. Anyway, right. So let's just put that here. Right. Now, you tell me now, in your own words, you've had 2 demonstrations, and I've given you extra information. How do we get from the question to 7/8?
Okay.
How do we get from here to here?
Can I use what I learned in the video?
Yes, please.
Okay, so when we start from 0 to 1,
Yeah.
that would be what was it? 4/4 on the first one.
So here you're saying it's 4/4, yeah?
Oh no, sorry, on 0. So that would be 4. Yeah, that would be 4/4 here.
And that's 0. Okay, that's fine. Yeah. All right.
So then it would have been let me remember. I'm just trying to remember how it went from 0 to 1.
Yeah, go back to the question, work out the fraction that is halfway between 1/2 and 1/4.
So it'll be 4. That'll be 2/4 in the middle.
In the middle, here.
Yeah, that'll be 2.
Yeah.
And yeah, that'll be 2/4. So that's okay. So here it will be 3/4 after 2/4.
Yeah.
Yeah. And then in the middle of 3/4 and 4/4, it will be 3.5/4.
Yeah.
So to find the middle, we have to times 3.5 by 2 because that's the denominator of the half.
Yeah.
And then we have to times 2 by 4. That gives us 8.
Okay. Very good. That's excellent. But I just want you to be absolutely clear, okay, that you are actually using these points.
Okay.
You know, like how he used it. Right? So can you see now that you must make sure that you are plotting the half. Make sure you are plotting the half and you are plotting the 1/4.
Okay.
And this is why you're having to go to the halfway point between 1/2 and between 1/4. And that's why you're going between 3/4 and 4/4 to give you 3.5 to get you 7 over 8. I think we are a lot better now at this question than before now, would you say?
Yes, I would say, and I was going to say, can we restart it? I want to explain it with the full points now.
Of course, my friend. So, okay, do you remember the information that the video gave, and then when I did some extra work, okay? So can you now, okay, start again. Let us start again, yeah. So tell me what you need to do.
So I'm just plotting down the graph in front of me so I can have a visual of what I'm doing.
Yeah.
So I want to change the one in the middle. I want to plot first. So the half will go in the middle, not on the one, not on the one.
You want to plot the, yeah, okay. So should we plot the half then, yeah?
Yes. So the half will be...
Where should we plot it? Here?
Midway. Yeah, there.
Yeah? Okay, all right, yeah. Next thing?
Next thing, a quarter, one whole quarter, so that'll be after the 1.
Okay, all right, yeah, good.
It's not showing up for me actually right now on the screen, what you're writing.
Can you not see it?
No.
Okay. Is that clear? Is that clear? Can you see it?
Nothing coming up right now.
All right, let me just double check. Did you see it before?
Yes, before when you're writing, I saw.
Oh, okay, right, okay. Let's just share it. Okay, can you see it now?
Could you write something? No, I cannot.
Oh, what's happened there? All right, let me just screen share it. Oh, hold on, let me just try and get it up. Oh, I don't know why that's not working. Okay, right. Right, can you see it now?
No, still nothing coming up.
Can you see it now?
Nothing coming up.
How strange. It should be sharing now. Right, is it coming up?
No, it's okay. We can carry on.
So what can you see then? What?
Just the 7 over 8 and my notes, the sticky notes that I had put on.
Yeah, that is all we've got because you asked me to rub it out. So.
Oh, I'm sorry. Oh,
yeah, you have to rub it out. So you can see the Jamboard.
Yeah, I can see the Jamboard.
Right, okay. Oh, sorry, I wasn't sure from what you were saying. Okay, my friend. So what we've done, it's okay, no problem. We're clear on things. So anyway, you've plotted the half and the 1 1/4. What do we do next? Bearing in mind, find the fraction that's halfway between these two. Carry on.
Okay, so that would be 2 over 4 in this sense, and then number 1 will be 4 over 4.
So you're saying here 2 over 4?
Yeah, that's
okay. Yeah, and then
that's 4 over 4.
Yeah, okay.
And then just after that, it will be one whole quarter. How would I say that fraction?
So you mean this fraction here?
Yeah.
That's 1 1/4.
1 1/4. Okay, 1 1/4 after
so let's just put 1 1/4 here. Okay, yeah, got it.
Yeah.
What's next?
So then we would let me remember. Halfway between. Okay. So it will be 1.
Right. What am I doing with my laser pen?
Halfway.
Halfway what?
Between a half and 1 1/4.
Okay. So where is that on the scale? You've marked out where the half is. You marked out there. How do we get the halfway point between these two?
We would put 3 over 4 just after the half.
Yeah. Okay. Just put it here. Okay. Yeah. Got it. Yeah.
So we would have done. I don't remember.
Okay. I'm going to use my laser pen. Okay. This is the half.
Yeah.
Which is 2 over 4. This is 1 1/4.
Mm-hmm.
Now listen carefully. Is the halfway point between a half and 1 1/4, is that the halfway point here?
Yes. Yes, it is.
Hold on. Listen carefully. The halfway point between a half
Yeah.
and 1 1/4. Between these two.
Oh,
Is
it
the
is.
halfway point here?
No, it's not. It's the one after.
Is the halfway point here?
No, just before the whole number.
Right. Is it here?
No, just before that.
Right. Before that, here.
Between 3/4 and the whole number.
Right. Here.
Yeah. Yeah.
Excellent.
So that's
right. Okay. Right. Good. Good. Let me just write it down.
Mm-hmm.
Right. Now, what do we need to do? What do we need to do now?
We have to do. Let me see. Times it. Times 3/4, and then divide that by.
What do we need to do to get the
Add
halfway?
It.
Halfway.
Okay, we times it. So 3 times 4 equals 12.
No.
Oh, 3 plus 4 equals 5.
No. What's the
Oh,
halfway
sorry, 3.5. Oh, sorry, I
between 3
apologize.
and 4? What's the halfway point between 3 and 4?
3.5.
Right. Okay. Do you remember?
Yeah.
Right. So I'm gonna put an arrow here, and 3. So it's 3/5 over 4.
Yes.
What did we say about decimals as fractions?
It's improper fraction.
Okay. So what do we need to do?
So we then have to, in order to get 7/8, we have to do 2 times.
What do we have to do? Times what?
Times 2 by 3.5.
Right, and that gives you
7.
And how about 4 times 2?
8.
Okay, right. Okay, Jumberg. I think we've got there in the end. I want to give you a round of applause.
Thank you. I'm gonna do a couple more questions and send it to you after.
Yeah, that's fine. We are going to continue with doing some more GCSE. I've prepared some more foundation, non-calc, paper 1 questions for you in the session. But well done. I think last week, I think you were totally confused by this.
Yeah.
And I think as we've gone through the session, as we watched the videos and as I explained it, we've used the board, and you've also done some good work. Look, I mean, you have used information. Okay, look, the 5/4, that would work if you're using the non-number line. Okay,
Yeah.
so you're just basically comparing 2 1/4 with 5/4.
Yeah.
Halfway between 2 and 5 is 3 1/2. And you're gonna end up with this and then that again. Okay, so that bit's okay. All right, and also, yeah, look, half and 5/4. But then again, as the video said, you can't really use the half. You have to change to 2/4.
Yeah.
You can do something with it. Then you can then go 2/4. Okay. All right. So there are elements in this which work really well. Okay. This is not quite correct, is it? Well, actually, 5, 2 and 5. Okay. Is not 3. It's 3 1/2. This is where you made a calculation error. Okay.
Okay.
All right. So remember, this question is worth 3 marks.
Yeah.
Okay. So you're gonna be really careful with this question, that you are going through everything step by step. Okay, my friend. Let's go to the next question. Right? Can you see the question? Can you see my board? Right.
Yes, I can.
Right. So we're just following through with the AQA GCSE Maths Foundation, November 2018, paper 1. Okay. So this is what candidates did exactly 2 years ago. So x is a positive integer.
Yes.
35 plus x is a positive integer. Work out the 4 possible values of x. Now, I want you to listen very carefully to my question. Okay?
Yes.
So in this question, Jamborg, I'm going to ask you to tell me what integer means, okay? And I'm going to give you 3 options. Listen to all 3 options very carefully.
I will.
Number 1, positive integers are whole numbers only. Number 1, positive integers are whole numbers only. Number 2, positive integers are fractions. Positive integers are fractions. Number 3, positive integers are whole numbers or fractions. Number 4, positive integers are decimals. Okay, now, which one of those is the correct definition of an integer?
Positive, because it says positive. I'm guessing it will be whole number.
Excellent, well done. Okay, now when we talk about integers, okay, an integer is whole. It's a whole number. Now it can also, you can also have negative integers, which will be minus, -2, -10, etc., -20. Okay, but the key thing here is it's a whole number. So this is not a whole number, is it? 0.5. Okay, 3/4. These are not integers. Numbers like 4, 100, 6. Okay, these are integers. These are not integers.
Okay, I see.
So tell me now, what is an integer?
An integer is a whole is a positive whole number, a whole number.
And is it a fraction or decimal?
No, because they are not positive numbers.
Excellent. Well, because they're not whole numbers.
They're not whole numbers. Yeah.
Yeah. Okay. They're positive, but they're not whole. Okay.
Okay.
That's the key thing. All right. Now, look at this very carefully now. 35 plus x. Let's write it down. 35 plus x. No, sorry, it's not plus. That's division. Sorry, my friend. You know, the copy is not very good, because I've had to screen print it. So just bear with me, okay?
Sure.
35 divided by x, okay? And what they want you to do is they want you to find out the value of x. What's the 4 possible values of x? Now, I want you to have a really good think about the number 35. Have a good think about it, because, and my clue is, what kind of factors can go into 35? Could the number of factors be a clue in identifying the values of x?
Okay.
So my question is, what goes into 35? What numbers can go into 35 without leaving a remainder? What factors can go into?
So 5 times 7 would be 35.
Yeah, you got 7. Yeah, good.
Yeah.
5. Yeah, 5 as well. Very good.
Oh, okay, I understand a bit now. Let me see what else. So there are 4 possible answers.
Okay, can you write in your book 35 and then put 2 arrows, and then basically I'm just going to stop the share, and then I'm still keep guessing, and then I'm going to ask you to tell me what the answer is.
Sure. Oh, okay, it has to be positive numbers. So will it be 1 times 35 because that equals 35?
Okay, so can you write the answer down?
Yeah, sure.
Okay, so you're saying you're saying it's 7, 5, 1, and 35.
Yes.
Yeah, correct. Well done. Okay.
Okay.
Well done. Correct. That is good. Well done. That's 1 and 35. So basically, the numbers that go into 35 without leaving a remainder. If we do a check, okay. So for example, if you did 35 divide by 35, what answer would you get?
Yeah, 7.
Listen again.
Sorry.
Divided by 35.
That would.
How many times does 35 go?
By 1.
Yeah, divide
1.
by any number that divides by itself is a 1. Excellent. So that's one value, right?
Yeah.
Now, if we did 35, so we're doing a check. 35 divided by 7. What's the answer?
5.
Excellent. What about 35 divided by 5?
7.
Okay. And what about, 7. And what about 35 divided by 1?
35.
Excellent. Few rules then. Any number divided by 1 is the original number. Any number divided by itself is a 1. Okay? And can you see the connection here between the times table? Yeah?
Yes.
So 7 times 5 equals
35.
35. 5 times 7 equals
35.
Yeah. And can you see the relationship between multiply and divide?
Yeah.
When it switches, it's the other way around. So 35 divided by 7 is 5, or 35 divided by 5 is 7. Okay. Yes. So don't be put off by words like integers. Okay. As long as you know what the meaning is, and then you connect it back to the question, and it's saying that there are four values of x, and x must be an integer, a positive integer. So you got 7, 5, 1, and 35. They are all positive values of x, and they're all positive integers too.
Yeah.
Right. Well done. We didn't spend that long with that question. Excellent. And look, Jamber,
I know this now.
Good. And look, fantastic. You are getting 2 valuable marks there, aren't you? That's really valuable marks. Okay?
Yeah.
Right, my friend. Now, for this exercise, I have put in, can you see the dice?
Yes, I can.
Okay. So I have put this information as an extra. It's not part of the exam question, but I thought I'll put it in here for teaching purposes because it might help you. Okay?
Sure.
Now, have a little think about what the answer might be. I want you to try and do this yourself for the next few minutes, right?
Okay.
A fair dice, like a normal dice, has 6 sides, numbered 1 to 6. After it is rolled, 5 of the numbers can be seen. Write down the probability that one of these 5 numbers is a 2. Right. Now, how do we normally express probability?
It was higher chance, low chance. I forgot the actual terminology.
Okay, listen carefully. Okay, yeah. I'm going to give you 4 options. 1, 2, 3, 4. Okay.
Okay.
Number 1 is probability is like a number.
Yeah.
Number 2, probability is like a fraction. Probability is like a percentage. probability is like a decimal.
Okay.
Which of those three options represents probability? The chance of thing happening. Which three?
I think I'll say percentage.
Yeah.
Fraction, because you can turn them both into each other, and a decimal. Yeah.
Excellent. So when you talk about there's a 50% chance of success.
Yeah.
That 50%. Oh, okay. Sorry, let me just rewrite that.
No worries.
So 50%. Or 0.5, all these are expressions of probability.
Yeah.
But normally when we are speaking and we're talking about the chance of something happening, we tend to use percentages. But because we're doing a maths exam, they may say to you that the probability, express it as a decimal or as a fraction. Okay? So again, knowing how to get a fraction or a decimal from a percentage is very, very important work. Okay. But anyway, we won't worry about the conversions for now. But what I wanted you to do, which is very good, is you now understand that the probability can be expressed in three different ways. And I want you to try to now, it's your choice. You can express it as a fraction, percentage, or a decimal. Write the probability that one of these 5 numbers is a 2. And if you want to use the dice, if the dice is going to help you, look at the dice carefully. Look at it very carefully.
Okay.
I'm going to expand it now for you. Write down a probability that one of these 5 numbers is a 2.
Which one did you say I should? Did you say I should use a percentage or a fraction? Or
it's up to you. It's up to you. I mean, again, whatever you think is best, because you got 3 options.
Okay. Would it be 0.6 in terms of decimals?
Right. Where's 0.6 come from?
So because there are 6 sides,
yeah,
I remember doing something about finding decimals with whole numbers. So I did 60 divided by 100, which when you take the 0 away, it gives me 0.6, because the 6 moves over and then it adds a decimal point.
So you're saying it's 60% chance. So are you relating? Okay, all right. So let me use my laser pen. You know the 60%. Are you relating it to 6 sides?
Yes.
Okay. Let me ask you. Okay. Let me ask you a question. Okay. If say for example, right. If say for example, the number. When you play dice, it's normally the top, isn't it? It's normally the top that you can see, isn't it? Yeah. Okay. All right. Now, just for the purpose of this exercise, all right, I just want you to, if I take this out, yeah.
Okay.
Now, and say, right, this now relates. The 2 relates to this side. Okay? Right. Now, the probability that one of these 5 numbers is a 2 is going to have to take into account how many numbers you're going to have. You're going to have, there's a chance that the actual 2 is going to be here. There's a chance that the 2 can be here. The 2 could be there. The 2 could be here. The 2 could be behind there. But there's not going to be a number here. Remember, the question is saying, read the question carefully, 5 of the numbers can be seen.
Okay. Okay.
Now, if you think about it, a dice has 6 sides, yes?
Yes.
And then when you put the dice on the floor, how many sides can you see?
3.
3 or 5?
Oh, 5. Yes, because it says 5 can be
Right?
seen.
Because you got the 2 sides either side, and then you got the top, right? So that means then, so one of these 5 numbers is a 2, but what is the chance of seeing? What is the chance? So say, for example, the maximum is going to be 6. But you can't see 6 here, right? You can't say 6 over 6 because only 5 are viewable.
So it'll be 5 over 6?
Right. Can you explain why? Why is it that it's 5 over 6 is the probability?
Because once you roll it, there are only 5 numbers available that not available, but you can see visually. So
yeah,
there's a higher chance of those 5 numbers being, what them being 2.
Yeah, that is there is a high. That's a very good point. 5 over 6 means a high chance, and there's a high chance because look, you could see it here, you could see it here, you could see 2 there, you could see 2 behind there, and you could see it behind there, but you can't see it here though. You can't see the bottom one. So there are 5, like what? Okay, 1, 2, 3, 4 behind. Yeah. And then 5 behind there, but you can't see the 6. That is not possible. Well done. Very good. Okay. Now, let's just take this picture and reduce it. Okay. Now, the question is saying, work out the greatest possible sum of the 5 numbers. Now, look at the question carefully. The greatest possible sum.
Okay, so it's saying, does it mean add up the numbers that can be seen?
Yes.
Okay, but how would you know which one is seen, because...
But then you have to then work out the greatest possible.
Okay.
The greatest possible.
Okay, so...
Okay, what I'm going to do, I'm going to give you a bit of a scaffold. Each of these squares, not very good writing, but each of these squares, okay, represents the side of a dice.
Okay, so would it be 21? Greatest possible sum.
Right, so why is that?
Okay, no, it wouldn't, because there are 6 sides, but we're talking about 5 numbers.
Only 5 can be viewed. Okay. Yes. So which one are you going to be viewing?
1, 2, 3, 4, and 5.
So you're saying 1, 2, 3, 4, and 5. And what's the total?
16.
Right. Is that the greatest possible sum?
Of the 5 possible numbers?
Yes.
Yes, it is. Oh, okay. Now I do understand. Okay.
Yeah. Sure. Are you sure? Right. Okay. Try again. I'll rub it out. Oh, okay. Sorry. Oh. I need to put images next time. Never mind. Right. We'll use a different color. Right. Okay, Camberg. Now try again. What's the greatest possible sum? The greatest. And you said now 5 numbers. Right. Yeah. Pick the highest 5.
6, 5, 4, 3, 2.
Right. Okay. Now we're talking. So what's the sum of all that then?
20.
Right. So you've got 6
plus 5
is what? 11. 11 add 4 is
15.
15 add 3.
18.
Okay, 18 add 2.
20.
Well done.
Okay, I like that.
Greatest possible sum, because 1 is going to reduce your numbers. You can choose 1, but it's not going to give you the greatest possible. You have to include the highest numbers. So say, for example, Jambo, say, for example, you throw the dice and the 1 at the bottom is a 1.
Yes.
Then you've got 2, 3, 4, 5, 6 to see, isn't it?
Yeah.
And that's why it's the greatest possible one.
Yeah.
Fantastic. Okay. Excellent stuff. Okay.
For the first,
yeah, go on.
For the first question, does it matter what you use, decimal, percentage, or fraction? Can you use any type of answer?
I think that as long as, okay, if you are, I think 5/6 is the easiest way to express it. Because you've got 6 sides, which is your denominator, the total. And the total number of sides in the dice is a 6. So I think fraction. However, if you are being ambitious, I don't see why. I mean, remember this, it's a non-calculator paper.
Yeah.
So you can't, so if you knew what this was as a decimal or a as a percentage, brilliant. Yeah. That's brilliant. But if you don't, it's always best to play safe and just choose the fraction option. Remember, we said 3 of them are acceptable ways of expressing probability.
Yes.
Okay then, my friend. But there may well be certain questions in your GCSE where they specifically say you must express the probability as a decimal or as a fraction or as a percentage. Okay?
All right.
Marvelous. Well done. Right. I think we've got time for one more question, Jamberg.
Sure.
Right.
Okay, I'm hoping.
So number 12, work out 2/7 plus 6/7. Circle your answer. So you've got 1 and 1/7, 8/14. You've got 8/49, and then you've got 1 and 5/7. Okay?
Okay.
So what I want you to do is I want you to have a little think about that. Tell me what the answer is.
I've got the answer already. Okay, because from the question we did before, I'm now a bit more used to with the timesing and the actions.
Yeah.
So we have to first find the denominator. So it'll be 7 times 7, which gives me 49. And then we do 6 plus 2, which gives me 8.
So you're saying, right. So you're saying 7 times 7.
Is that not 6? You wrote 8 here. You wrote 2 plus 8.
Okay. I was just...
Of course, I saw it wrong again.
Okay, right. So you're saying 6, and that gives you 8.
Yeah.
Okay. So you're saying it's this answer?
Yeah, 100%.
Right. Let me ask you a question.
Okay.
Why do you think the examiner has put an incorrect answer like 8/49? I want to commend you for trying, but unfortunately the answer is incorrect. But why has the examiner put 8/49?
Because it looks like the easiest answer for someone, you know.
It could well be. And again, you don't, when you are doing work with fractions, you don't mix the arithmetic. If say, for example, all right, if the question was, Jamberg, they may say in a GCSE, okay, what's 2/7 times 6/7? Okay, that would be 12/49. Because what you have to do is you have to multiply the numerators together and then multiply the denominators. Okay? What you've done is you've got yourself a bit confused. You've used the multiplication of the denominator, and then you just used addition for the other one.
Yes.
Now,
because I have one attempt at it.
Yeah. So can I just give you a clue? The 8-bit, you're on the right path. If you put 8 in there, you're on the right path. But you're not. So tell me now, how would you correct it now?
Okay, so I would do. I wouldn't times the 2 denominators together. I would do 7 times 2, which would give me 14.
Right. So are you now saying to me that you are going to be now multiplying these two together?
Yes, that's one time. Yeah.
I thought when you've got 2/7, this is another way of expressing 2 divided by 7.
Oh, I meant times. I apologize. Times. So you do 2 times 7, not divide. So times.
Okay. Are you saying then? Okay, 2/7 is going to be 14. Okay. So what do we do next?
And then do 2 plus 6, which gives us 8.
So you've already used the 2. Are you saying to me you want to use the 2 again? So, okay, you've got 14 and 8. How does any of this relate to any of the options given?
Because there's 8/14 before the 8/49.
Okay, right, Jamberg, I'm going to ask you a question straight up.
Yeah.
Do you know how to add fractions together, yes or no?
No, I thought I did, but nothing more.
All right, okay. Now, we have done some similar work on this with the number line activity, okay? Now, I'm just going to very quickly teach you how you can add fractions together. And then once you know this, you should be able to subtract them as well, but one thing at a time, okay? So you've got 2/7 plus 6/7. Now, when you are adding up fractions, you've got to look and see what's happening with the denominator.
Okay.
Now, the key thing is when you're adding up, you've got to equalize the denominator.
Okay.
Now, 7 goes 7, perfect. That's not going to, so what you have to do then is by doing that, you are then going to leave it as a 7. Okay? And then you can add the 2 plus the 6 gives you 8. Now, have they given you 8/7 as an option?
No, they've not.
Right, okay. So, which option do you think relates to 8/7? Remember what we talked about in terms of using mixed numbers and changing them to improper fractions. What do we have to do? Do you think 7/8 has got any connection with this one? 1 and 5/7. Has it got any connection with this one?
This is denominated. It does, but
okay, but not fully. Okay. What about any connection with 7/8 with 8/14? Any connection there?
The numerator
is not the same, right? Okay. Well, that is the same, but not the denominator. Right? Can't be that, right? What about 8/14? Could it be that?
8. It could, but we didn't add the 7 together, so it wouldn't. Yeah.
Yes, that's true. That's true. We didn't add them, so it's not that because we have to equalize them when we're doing addition. So the only option is this one. But why? Why is 8/7 top heavy improper? Why is that the same as 1 and 1/7? What did you do before in the other one? What did you do? Look carefully. What did you do?
Okay. So
what did you do?
I did 1 times 7, which equals 7.
Yeah.
And then you add the 1, the numerator, which gives you 8.
Yeah. So basically, when you're changing from a mixed number to a whole number, what you have to do is you have to the denominator multiply that by the whole number, WN, and then you have to add the numerator. But when you want to change it back, what you have to do is you have to divide. What you have to do is you have to divide the numerator by the denominator.
Okay.
And when when the numerator is top heavy, you have to say, okay, how many 7s go into 8? Oh, it goes into 1. Right, and what's left over? 1.
Oh,
Then the remainder is a 7th.
I see.
Can you see now why it's
Yeah,
7 over 8?
not,
But what you've got to do is you've got to learn how to add fractions together.
Yeah.
Okay. Right, Jan, it's over. Yeah, sorry, go on, carry on.
There's one question. Let's say if it was 2 over 7 plus 6 over 5.
Yeah.
Would I would have to make the denominator the same, wouldn't I?
Okay, yeah. Now, here, let me show you how to do that. This is where you're getting confused with multiplication. Okay? So repeat that again. Say if it's 2 over 7,
yeah, and
add 3 over 5.
Yeah, 3 over 5. So would I have to make the denominator the biggest number?
Yes. And the only way to do that is you need to find the biggest common number.
Okay.
You've got to find the biggest common number that will go both into 5 and 7 without leaving a remainder. Okay? And this is where the easiest way to do this is to multiply.
Okay.
Okay?
Okay.
Now that will give you, that will give you 2. So basically, when you multiply together, it becomes 2 over 35. Add 3 over 35.
Yes.
Now they're equalized. So it's going to be over 35. And then you add the 2. And then you add the 3. That becomes 5.
Yes.
Now, because you have to simplify that, because the 5s can go into 35 7 times. Okay? So basically, 5 goes into 5 the once, but it goes into 35 7 times. So the answer is a 7th.
Okay.
Okay? That's where you're getting confused. But if you've got 3 over 5 plus 3 over 5, it's going to be 6 over 5, the answer. Okay? If you've got, say, for example, 2 over 7 plus 3 over 14, then fine, we can work with the 14. We have to now bring the 7 up to a 14 by multiplying the denominator by 2, and then we have to multiply the numerator by 2. That becomes 4 over 14 times, add 3 over 14. That gives you 7 over 14. And remember, 7s can go into 14 twice. 1 and 2. So your final answer is a half. Okay?
Okay.
What I'm going to do, Jamberg, is, on the Padlet, I'm going to find some quizzes for you. So you can really work on adding fractions together. And hopefully, remember that question is worth quite a lot, That question is worth, it's not worth a lot, but still is an important mark to have under your belt. Okay? Now, listen carefully to your homework. I'm going to ask you to do, this link, you should still be able to get the link. So go on the Jamboard, okay? And I want you to answer question 14. The nth term of a sequence is 5n minus 2. Work out the third term. I want you to do that question, and I want you to use Post-its, use the writing, and I want you to try and get to the answer. And then I'm going to ask you to do some additional work, which I'll post on the Padlet, right?
Okay.
I'll put it on the Padlet, which is here. This is your Padlet. So I'm going to put your work under session 4. I'm going to put it here. Okay? What you need to do. So I'll write it in there. And then by Wednesday, can you have the work completed?
Sure.
And then can you send me a WhatsApp message to say you've done it?
Okay. For which day?
by Wednesday, by the end of Wednesday.
Okay.
Okay?
Okay.
All right.
I'll definitely do.
All right. So it's just that one question, question 14. And then I'm going to give you some maths fun questions on adding fractions. All right.
Yeah.
And then we'll do. Okay, then, my friend. So let me quickly ask you now a question. Can you see the traffic lights?
Yes, I can.
Okay. How much do you think you've learned today? Red, you not learned anything.
Green.
A little bit. Red, green, lots.
Green face, 100%.
Yeah,
green
well
face.
done. And I want to thank you for all your efforts in the sessions and the homework. I think you're really trying your best. And I think the fog is slightly beginning to clear, isn't it? Slightly.
Yes.
Yeah, well done. Well, you just keep working hard. You're doing very well. And then obviously I'll give some feedback to your father, possibly tomorrow or sometime in the week. Okay, so I'm going to now, remember this, go back to that Jamboard link, do question 14 on the nth term. Okay, and then I want you to do some questions, some quiz questions, which I'm going to post in the Padlet. Okay, my friend.
Okay,
take care then. Enjoy your weekend. Bye.
Bye. Take care.
Bye. Bye.